the first of what I hope will be several live streams that I'll do periodically throughout the semester. Um, this is for my second semester Java programming course, and in this one we're trying to take a brief look at some of the built-in data structures that Java gives us, along with doing some more advanced programming techniques. And so since this is just one of the first weeks of the semester, we are going to take a look at one of the first data structures, and this one is called the ArrayList. So I want to show you a couple of things tonight. First of all, how is the ArrayList used? In other words, how would you use it in your program? And then secondly, I want to take a brief look under the hood and find out a little bit about how it actually works. Okay, so when we left off, we had implemented a couple of classes, one representing a bank account and one representing a bank. So let's take a brief look at both of them to refresh our memory. So this one here is the account. It's got three fields in it. It's got an account number here, an owner, and a balance. We've got a constructor that just simply takes in all three values and stores them in the fields. And we've got two methods, one called toString that simply returns a string containing all three values in it, and one called adjust, where you give it an amount and it adjusts the balance up or down depending upon whether the amount was positive or negative. Okay, and then we've got our bank. A bank holds an array of accounts. Okay, so maybe previously you've only seen arrays holding things like strings or integers, but it's in fact possible for arrays to hold any one type of thing. In this case, we're going to hold accounts. And then we've got a variable called next that keeps track of where the next account is going to go into the array. We've got a constructor that initializes the array. So this is a very small bank, so there's only going to be 5 slots available. And then we set next to 0. Okay, and I'll explain why we have to do that here in a moment. And then I have a method here called add account that takes in an account and adds it to the array and increments the next variable. I have one called display that simply iterates through the entire array and prints out all of the accounts that it finds. And then the last one called apply fees that again goes through all of the elements of the array and adjusts, actually applies a $2.95 fee, which presumably would be like the monthly charge for all of the bank accounts. Okay, so let's see how this gets used. So I'm going to use BlueJay's CodePad feature here. And first I'm going to initialize my bank. So bank, let's call it B equals new bank. And at this point, I should now, within the bank, have an array with 5 slots in it, but none of the slots have been filled with anything. And now I can say, let's make an account. So account A1 equals new account. And let's call this account number 100. The owner is George. And the initial balance will be $50. And now I want to add this account to the bank. So I go b.add account A1. And if I say b.display, I get a pop-up saying that bank account number 100 is owned by George and has $50 in it. So let's make another account. Account A2 equals new account. Let's say this is account number 101. This is owned by Jane, and she's got $100. And now we will add it. And then if I say b.display, this is the output from the previous display, so ignore that. This is the new output here. It's showing that there's 2 accounts, number 100 and 101. George and Jane own the 2 accounts. One's got $50 and one's got $100. Okay, and in fact, you don't have to create the account separately from adding it. You can in fact do it all at once because the thing inside of the parentheses right here needs to be something that's a bank account, something that's an account. And it turns out that when you say new account, that gives you something that's an account, and we know that it is because we can assign it to a variable of type account. So I could actually say b.add account, and then right inside the parentheses I could say new account 102, and let's make this owned by Tim, and this one has $75, and I'm missing a parentheses, and I'm missing a semicolon. There we go. And now if I say b.display, I've got all 3 of them in there. Okay, so I'm trying to show you here that you don't need to explicitly make the account separately from adding it. You can in fact just add it and create it at the same time. Okay, so let's draw a picture of what this looks like at this point. So here's my bank, and it is actually just, so the bank basically is, let's use this box here, and inside that box there are 5 slots in the array, and the array is called accounts. But it's not labeled like this. Okay, that may be how you've seen this drawn in the past, but that's not actually how it is. There is within bank another box that is labeled accounts. Its type is bank array, and it points to this array that is indexed 0, 1, 2, 3, and 4. And then there is another box. I need a little more space here, so let's erase that. There's another box called next, and its type is int, and its value is 0. Okay, because the element number 0 is where the next bank account is going to go. Okay, so this is my bank. And then I say account A1 equals new account 100 George 50. And so what happens there is I end up with a box called A1, there's a type account, okay, and then an object of type account that has 3 fields. This is account number, I'll just label it num, and owner, and it needs a little more room, so let me erase that. Balance. And this was 100 George 50. Okay? And then this points to that. We good so far? And then when I say b.add account A1, then what we get here is, let's see, so inside the program, if I switch back to that, and I look at the bank, inside of add account, it says put A, which is the account I'm passing in, into the array element pointed to by next. So what that's really doing over here is it's saying take whatever's stored in A1, and the conceptual model we should have here is that what's stored in A1 is actually a memory address. So there's actually a number sitting here. We can't see the number, but there is a number in there. And let's just say for explanation purpose, let's say that number sitting in there is 5,000. That's the memory address of where this object is sitting. Okay, so this statement here that says accounts bracket, let's write it over here. Accounts bracket next equals A. That's the statement from inside the bank account. What that's going to do is it's going to take the address stored here in the account being passed in and put it into element number 0 over here. So it is, you can think of it as putting the number 5,000 right in that spot, but it has the effect of making this box point to the same thing that A1 is pointing to. So it's not pointing to A1, it's pointing to the same thing that A1 is pointing to. It's transferring that number, there's a number 5,000 in both boxes, So it means that both those boxes are pointing to memory address 5000, which is my account object up here. Okay, and then this number 0 becomes the number 1. So the next bank account is going to go into slot number 1 up here. Okay, so that's kind of a picture as to what's happening inside of our bank. So every time we add an account, it goes into the next slot. We bump up the value of next, and bump it up, and bump it up. Okay, and so when we add another account, there's going to be another object sitting in memory somewhere over here. There's going to be another variable pointing to it, and then we're going to end up with an arrow pointing over here, and the picture gets more and more complicated. Okay, so let's add a few more accounts to our bank. And I made it artificially small, right? It's only 5 slots. And what's going to happen if I add that 5th account? So let's go ahead and add another account. This is a bank account 103, and this one's going to be owned by Jan. And let's say there's 200 in there. And this is Dawn, and let's say there is $120 in there. Okay, so now if I go display, I'm going to see that there's 5 accounts there: George, Jane, Tim, Jan, and Dawn, each with their respective amounts of money. And then what's going to happen if I add another account? Let's make this owned by Sarah, and that'll be, let's say, 250. Oh, I made a misspelling there, so let's go back and change that. There we go. All right, this is the error I'm looking for. We get an array index out of bounds exception at element number 5. So this says that we ran off the end of the array, which is kind of what we expected. So what's the bank to do here? What should the bank do? The bank has now outgrown its array, and what should it do? Well, of course, the programmer would say, well, let's just bump this number up to 10, or maybe 20, or maybe 100, or maybe 1,000. We got to recompile the program, and then we've got to put all the bank accounts back into it. But you're always going to run into this problem of what happens if we get so big that we run out of elements of the array. So really, we've got, so what the bank needs to do is it needs to make some kind of array that can expand itself. But all we have here are fixed size arrays. We have arrays that can only be one size. So the solution there is to use this built-in data type called the ArrayList. And so let me switch over here to a new screen. So this is called ArrayList. Okay, so the idea is it acts like an array in that you got boxes that start numbering at 0, 1, 2, 3, 4, and so forth, but it's expandable. And so a list is a data structure that's expandable, so this is a list that acts like an array. So it is expandable. Its whole name is java.util.ArrayList, and there are some methods that you should know about. There's one called add. So you can add an element to the array, and what that does is it sticks it onto the end of the array and essentially grows it by 1. So initially the size of the array is 0. When you add something, it becomes 1. When you add something else, it becomes 2, and so forth. There is size, which tells you how many elements are in the list or in the array. There is remove. And what you do is you give it an index number. I say I want to remove element number 2, and it will pull that one out and then slide everything down so that it compacts it down. And then there's get. You give it an index number, and it returns the element at that position. Okay, so let's show how we are going to modify our bank so that it uses the array list. So we're going to get rid of this. We're going to say this is not going to be a private fixed size array. This is now going to be a java.util.ArrayList called accounts. And we also don't need to keep track of how many elements are in the array because the array list keeps track of that for us. So this is actually good from the bank's perspective because the bank doesn't, its responsibility is not really to keep track of arrays. Its responsibility is to keep track of accounts and the amount of money in each account. So it really doesn't want to be in the business of keeping track of arrays. So it's nice that we have this thing called ArrayList because it abstracts away the idea of managing the size of the array and lets the bank just focus on what's important. So right here, I am making my new array list, and the whole name is java.util.ArrayList. There's going to be one little bit of syntax I'm going to need to throw in there in just a moment, but I want to show you here that so far nothing looks that unusual. Actually, you might be saying, this looks unusual. I've never seen this used of the whole name before. This actually works just fine. You can refer to a class by its whole name, and you don't need to import anything. Now, if I wanted to refer to it by its short name, which is just ArrayList, I could write an import up here, import java.util.ArrayList. And then I could use the short name. So the only thing that import does is allows you to use short names. It doesn't actually make the class available to your program, which I think is probably a concept that a lot of people have. You don't need to do an import. If you don't want to do imports, you can get away with not doing any at all. You just got to refer to all of these classes by their whole names. Okay, now here in add account, I don't need to do anything like this. I just say accounts.add a. Okay, and remember add was one of the methods that I showed you on the previous slide. All we do is we tell the array list to add this account called A to its list. And then for display, I'm not going to use this array notation anymore. I'm going to use get. So I say accounts.getI. So this is equivalent to using the brackets with the I inside, except because this is a method, I need to use parentheses and put the number inside. So this is exactly equivalent to the old one. I'm just going to put it like this. Okay, remember that old one there? See the brackets here? So that was how we used it for a fixed size array, but now we're using an array list, we need to use get parentheses I. The rest is the same. I have accounts on the left side and I have toString on the right side. This is the old way. And then again, for apply fees, I'm going to put get I there, and then call adjust on the thing that comes back. Okay, and then I don't need next up here anymore. I'm going to use accounts.size. Okay, and the same thing here. Okay, so I'll get to that error in a moment. So those are the changes I need to make to my bank. Let me digress for a moment and show you how to use ArrayList sort of in general. I probably should have done this a moment ago. So let's go import java.util.ArrayList. Actually, I'm not going to do the import. I'm going to show you can do this without import. I'm going to go java.util.ArrayList. Let's call it Al. Equals new java.util.ArrayList. Okay, so notice I'm referring to it by its whole name. I didn't do an import. Now I go al.add, and let's put like the number 5 in there. And let's go al.add the number 10. Oops, al.add 10. And then if I go al.get 0, we see that that's an integer. So let's see, we need to look at the value. So we do that, we can see that the number is 5. And if I say al.get1, I can look inside that and see that it's a 10. So I put a 5 in, I put a 10 in, and then I got number 0, the 5 comes out, I got number 1, the number 10 comes out. So this works a lot like a fixed size array, except I can just add, and it never gives me an error about array index out of bounds. It will, however, give you one if you try to get, let's say, element number 2, and you haven't actually added element number 2 yet. So it keeps track of how many things you've added to the array, and if you try to get beyond the end, then it gives you a, what am I saying, exception here. Okay, I can say al.size, and it tells me that there's 2 elements in the array. I can say al.remove element number 0, and then go al.get. Let's see what's in 0. That should be number 10. So I removed the 5, that was an element number 0, and the number 10 slid down into that spot. And so the whole array is now just 1 element long. And then if I say al.remove 0, and I ask it its size, it's now 0. So the array is expanding and shrinking as I add and remove elements. Okay, so that's what's going on here, is I just make my new array list, and then I add an account, and I don't care about making it bigger. The array list will just do that for me. And then my loop accessing individual elements works pretty much the same. I just use the get method instead of the brackets. And then here we've got an error. It says can't find method called adjust. And so this is the one little syntactic twist here, is that what we have to do for array lists, and I should have done it here, is let's do this. So let's go import java.util.ArrayList. This is just, again, to save a little bit of typing. So now I can go ArrayList, and now here's the syntactic twist, is I need to tell ArrayList what type of thing is being stored in there. We saw a moment ago that actually I can make an array list and I don't have to tell it. But really, to be proper, I need to tell it. So I'm going to say this is an array list that holds integers. Okay, so here's the new little bit of syntax. Is inside of angle brackets, after the name of the class, you tell it what type of thing it's going to store. So array list is going to hold integers. I have to do it in both places. Now if I go add 5, it's going to work just fine. And if I do al.get 0, it's still going to return an integer. It's 5, but here's what it gets us, is if I try to add, let's say, George as a string, I'm going to get a big old error here, which says that I can't add George to the array list because I've told it only stores integers. Okay, so let me switch over here and let's summarize that. So you say import java.util.ArrayList. Then you say ArrayList bracket, and then in the brackets there you put a type, like, and it has to be one of the capitalized object types. It can't be like int. It's got to be integer. And then you give it its name equals new array list, and you put the type in there again, and then your 2 parentheses to complete the constructor. All right, so that's the general syntax for making an array list, and this part here is the new thing, the thing you probably haven't seen before. Okay, so let's go back to my program, and I have to do that here to say that this is an array list of accounts. Okay, and once I do that, it should compile just fine. Okay, and the reason for that is because now the array list knows that when I do a get of element number I, it's going to be an account that comes back, and therefore I can call the adjust method on it. All right, so let's try out our bank now. So now I can go bank b equals new bank. I can b.add account, new account 100, George 50. Okay, b.add account, new account 101, Jane 100. Actually, I think I've got all of these somewhere up in here. Here we go. Oh, they're not that far back. I don't remember all the names I used. This is going to be dot. What was that there? Oh, that was a misspelling. There we go. Let's see, 100, let's do 103. Tim, say $75. Let's do 104. That was Sarah, I think. 250. Okay, so now if I go b.display, here's my 5 accounts. Let's say 105. I'll use my name. I don't have very much money, so see, so it accepted it. So it didn't stop at 5. It now just lets me keep going. Okay, so now there are 6 accounts in here, and this error you're seeing at the bottom is actually left over from the previous time when I had an error. So right now it's not generating any errors at all. It's simply letting me add accounts, and the array appears to be growing and growing and growing. So as far as the bank is concerned at this point, there are 6 accounts in the array. Okay, it doesn't know that how this thing actually works under the hood. And this is the whole idea behind abstracting away the behavior of a data structure. ArrayList frees you from having to know how this thing works under the hood. It looks like an array. It acts like an array. They're indexed from 0 on forward. It's got a size and so forth, but it always appears to be exactly as big as it needs to be. So right now, the array appears to be just 6 elements long. And as far as the bank is concerned, that's how big it is. Now, I said earlier that we'd be looking under the hood a little bit, and so that's not what's really happening under the hood. Java only has fixed size arrays. That's all we've got to work with, and that's all you worked with in the past. So what it's done is it's created this illusion. It's taken a fixed size array and wrapped it up with some methods that I call a little bit of magic, but it's not really magic. Wrapped it up with some code that makes that array expandable. But again, all we have is fixed size arrays, so it's just an illusion that's being painted by the programmer. I want to show you a little bit about how it works. All right, so I said earlier that in the bank there was this fixed size array. So let's just talk in general terms here, that now I have an array, let's call it ARR, and let's just make it be ins for now, or integers. Integer array. Okay, so behind the scenes there is a fixed size array, and that array has to have an initial size. What you want to do is you want to make it big enough so that as you start putting things in, there's space to grow. But you don't want to make it so big that you're wasting memory. So let's say 5 is a good size. Okay, and so we start putting numbers in. So let's say we put in 5, 10, 2, 3, and 6. So we've filled up the array. And we also need to have another variable called next that tells us where is the next element going to go. So the very next element is going to go into number 5. As soon as we insert it, it's going to get an error. That what next also tells us is that there are 5 elements in the array. 1, 2, 3, 4, 5. So essentially, this next variable does double duty. It tells us not only where is the next one going to go, it tells us the length of the array or the size of the array. So, and in fact, in some implementations, this is not called next. This is called length or something like that, or size. Let's call it next. Okay, so what has to happen if we want to add another element to this? We only have fixed size arrays, so we are forced to now create a new array that is longer than the previous one. Now, you can make it 1 element longer, or you could make it double the length, or you can make it quadruple the length, or you can make it 5 elements longer. The point is it just needs to be a little bit longer. Okay? Like I said, you can make it 1 element longer, but that means when you add another element to it, you've got to do this work all over again. In fact, actually, I think I want to use that as an example. So I'll make it 1 element longer. So we had a question here, what class is this for? This is actually for a second semester Java programming course. It's not really a data structures course, although we do touch a little bit on data structures. The idea is to give intermediate or students who have done at least 1 semester of Java a little bit of a taste of the underlying data structures that are available to them. So ArrayList happens to be the first one that we're looking at. Okay, so we create a new array, and then what we have to do is we have to copy the elements out of this one into this one, and here to here, here to here, here to here, here to here, and then we can put our 6th element in there. So let's go ahead and copy them. So we'll copy 5 down, 10 down, 2 down, 3 down, and 6 down. Okay, so all the elements get copied. And then we'll put in our new element. Let's say it is 8. And then what we can do is we'll change where this points. We'll say this now points to that one. And then this one will get collected by the garbage collector or erased by the garbage collector and no longer exists because nothing's pointing to it. So now our array variable over here is now pointing to a new array that is longer than the existing one, the pre-existing one. And this is why this picture is so important, because this variable ARR hasn't gone away at all. It's not a new variable, it's the same one, we're just storing a different number in there. Remember, the number we store in here is the memory address of this array. So let's say this one was at memory address 5,000, this one's at 6,000. What was in there before was the number 5,000, and now we would just replace that number with the number 6,000. Okay, so all we did was just say, put into this box over here the address of the new array. Okay, so then what happens if we want to add another element? Well, we've got to make a new array. And this is index 0, 1, 2, 3, 4, 5, and 6. And then we do the same process again. We copy down this element, copy this one, this one, this one, this one, this one, and then we put our new element on the end. Let's say it's -1. Then we have this point to that new array, and we can get rid of that one. Okay, so that's how ArrayList works, is every time you add an element to it, it has to create a new array. Actually, I'm lying a little bit here. But essentially, every time you add a new element to it, it creates a new array that's 1 longer than the previous one. It copies down all of the elements out of the old array into the new one, and then puts the new element on the end, and then erases the old one. Okay, and the little bit of lie there is it doesn't really increase the length by 1. It actually increases it by some number larger than 1. The idea is that you want to make the array grow by enough so that when you start adding things in, you don't have to copy elements all over again. You only have to do that once in a while. So you might start out with an initial array size of, let's say, 20 or so, and then maybe make it grow by 10 every time you have to. So you can fill it up from up to 20 elements, and then as soon as that 21st element needs to be added, it grows to a size of 30, and then it puts that element in. And then you can add 10 more elements, and then it grows to a size of 40. And then you can add 10 more elements, and 50, and so forth. So the amount that the array grows by is really up to the programmer. A good programmer will probably do a little bit of research into this and find out what are the behavior of arrays. So in other words, if somebody adds an element to an array, how likely are they to add another element? And if the chances are pretty good, then you want to make it grow by a fair amount. But if the chances are not so good, you want to make it grow by a small amount. But you want to make this array kind of generic so it works for everybody, so you got to strike some kind of balance in there. So that's a little bit about how ArrayList works under the hood. It uses fixed size arrays. It just has to keep track of how big that array actually is, and when it fills up, it has to make a new array, copy the elements over, and then throw away the old array. In fact, let me write that down because that is critically important. So it start with array of some size, and then fill the array using the add method. So when array is filled, you can do a couple of things. You're going to make a new array, but make it longer than the previous one. Copy contents of old array into the new array, and I'm going to run out of space here, but then we're going to add new element, and then finally here throw old array away. And the way you do that is you just make the pointer not point to it anymore. Okay, so that's basically in a nutshell how ArrayList works. And what we're going to cover in our actual class is we're going to dive a little bit deeper here and start writing some of the code that makes ArrayList work. Right? So we'll actually implement this idea of creating a new array, copying the elements over, and then throwing the old array away. And what you'll find is that the process of doing this uses all the same stuff that you already know how to do. It uses array notation, it uses loops. That's basically it, right? So you can build ArrayList out of what you already know coming into this course. And that's the neat thing about ArrayList, is there's really not a whole lot new here. It's just a way to take the existing fixed-sized array and give it the illusion that it's growing as it needs to. And this is a really awesome data structure is built into Java. I'd say this should pretty much replace fixed size arrays once you get to know how this thing works. So anywhere in your program where you had a fixed size array but it needs to grow, drop in an array list instead. Now, if, for example, you know that an array is always going to be, let's say, 10 elements long, it's never going to be more or less than that, then go ahead and use a fixed size array. But for pretty much anything else where you kind of don't know ahead of time how big it's going to be, ArrayList is wonderful, right? It just grows as you need it, shrinks as you need it, and is always exactly the right size. And given that memory is pretty cheap these days, the fact that there's going to be a little bit of wasted space is not a big deal. Okay, so I think that's all I had for you tonight. If there's any questions, go ahead and pose them in the chat. I'll wait maybe about a minute or so and see if anyone poses anything. And if not, then I will say good night for now. In fact, I will say good night for now, and then I'll wait a little bit and see if there's any questions. All right? So have a good evening, and I'll see you all in class. Bye-bye.